Fernando Salvados from EODev, a French company. He's calling us out of Paris today. Fernando has 10 years experience as electrical engineering and previously worked with a company called Peak Scientific, which is a company specialized in hydrogen, nitrogen, and zero air generators. He has a strong international experience working in Latin America, Europe, Africa now. And for us, it's always a pleasure at AFSIA. We like languages. So it's always a pleasure when we come across other people who speak many languages, French, Spanish, Portuguese, English. I think maybe even a little bit of Hungarian. You might need to explain this, Fernando. And
that's right.
And Fernando got his MBA from La Sorbonne Business School in Paris. So this is a little bit of the background of Fernando, but I will now hand over to him so he can tell us a little bit more about EODev and what the company does, and more specifically this project they're working on in Nigeria. Fernando, you should just have received a message for co-hosting, and you should be able to share your screen and turn on your camera now.
Okay, thank you very much, John, for this presentation. Let me try to share my screen. Just let me know when you see it.
It is there. You can put it in presentation mode, and up you go. Yeah.
Yeah, thank you very much, John. So yeah, thank you very much for being present. I work for EODev now as a business developer, mainly for international customers, for both onboard and land-based products. So I'll tell you a little bit more about the company and the products that we have, and also the project that we have around in Nigeria. We just got like 20 minutes, so I'll try to do this the quickest way possible. But if you have any questions, I'll be pleased to answer all of them. So basically, this is a picture of a major event that we have made last year in Paris in the month of May. EODev is a French company, so we are based in Paris area, and we have lightened up the Eiffel Tower using our product, land-based power generator powered by hydrogen. So this was a totally zero emission event, and it was to show people that our technology was mature and that we were ready to go to the market. Just to give you some briefing about the origin of the company. So we come from the boat, basically from Energy Observer Group, which has constructed a totally autonomous vessel navigating for more than 45,000 miles with no emissions, electrolyzing the seawater, using this with the full cell, using solar panels, wind turbines, and etc. And basically, EODev, which is Energy Observer Developments, we were created in 2019 to commercialize and industrialize the technology that was once tested in the boat. So basically today we have two products. We have one for the onboard solutions, basically for propulsion and hotel load, for zero emission navigation, but also a land-based unit with the full cell inside to replace diesel gensets. So both of them are based on hydrogen and full cell technology. Some key numbers about the company. So as I mentioned, we were created in 2019. We are today 60 passionate people. We have raised 25 million euros. We are 4 patents, production capacity of 600 units. So this is really important because we are in the industrial phase now. It's not only a prototype, it's a final product, and with 3 sites in France. So you see some of our shareholders. We got Accor, Energy Observer, Groupe Moneyeur, Telem, Insurance, Toyota as part of shareholder as well, Amfuel. And as industrial partner, we got Toyota because all of our full cells are provided by Toyota, the same model used in Toyota Mirai cars. EV system, basically for batteries and power management system, and an area, which is, this is the production facility. Basically, our products are being assembled in an area, and also in Paris area, and they will also be responsible for maintenance and technical support of our units. This is basically the product that we have and that we'll be focusing on this presentation. It's a zero emission power generator using hydrogen as a fuel with an efficiency of 50%. So a very efficient product. It's a reliable one because we have tested the unit, the full cell on the boat. We have integrated this to the first customers. We have released the first units. We are in industrial phase now. Easy to use. We have developed a totally plug and play solution. We are supplying also a pressure regulation box to adjust the pressure, and it's also scalable. So we are talking about 100 kVA genset, but can go up to 1 mega VA or more using units in parallel. So it's totally scalable. To provide you some additional information about the component and the technology. So basically, this is the pressure regulation box. As I mentioned, it's a plug and play solution. So basically, the customer only needs to have a hydrogen storage system, and then it connects the bundle to this pressure regulation box. We drop the pressure to around from 11 to 15 bar, and then we connect it to the gensets. We use basically the hydrogen inside of the fuel cell. This is the fuel cell compartment. As an electrical chemical reaction of this, from the oxygen and the hydrogen, we produce electricity. So there's no combustion on it. There are no moving parts, which makes this equipment very silent as well, if you compare this to a diesel genset. And as an output of this chemical reaction, we just have hydrogen and heat in the outlet of it. So there are no carbon emissions, there are no NOx involved to that. We only have water, which can also be reused. So it's hot water, not drinkable, but that can be reused for toilet and etc. and heat in the outlet of it. So you see here we have a hybrid solution basically between the battery and the fuel cell. The battery is a 44 kilowatt hour that we have inside of it. Basically to have instant power and also to manage the efficiency of the overall efficiency of the product between the battery and the fuel cell. So basically the fuel cell recharges the battery when we have a lower consumption. When we turn the equipment on, is the battery that takes the lead and that takes the charge. And then we recharge the battery as we go on with our power management system. So it's a totally autonomous and intelligent system to manage the power. And here is DC AC power conversion. So basically in the outlet of it, we have AC voltage, 400 VAC and 230 VAC. And here you see all the levels of current that we provide with the sockets and also the fuse box, power locks. And it's also important to mention that it's a connected system. So we have a 4G SIM card inside of it. We have different sensors inside of it. So we collect all of data. The customer can check the power consumption, the hydrogen level they have, the temperature of the fuel cell, temperature of battery, error logs. So we can also do predictive maintenance before the unit breaks down. We can intervene. So this is really great function for that. Now, give you some more information about the project that we have in Nigeria. So basically, we are going international now. We have closed deals with different distributors worldwide, in Canada, in Australia, but also in Nigeria with our distributor EODev. And we have a project. I'm not mentioning the name of the company and exact the site because this is still quite confidential, but basically it's to replace the diesel genset. As you might know, in Nigeria, most of customers, they use diesel gensets as a major power source power. So basically right now they're using diesel gensets and they're looking for zero emission solutions. And then we are trying to provide the GH2 to replace these diesel gensets. So basically we're trying to provide a zero emission solution for this customer. They have a requirement of around 1 megawatt per day, which is quite massive for its industry sector. And so basically they are using these gensets 20 hours per day, and they require that as a prime power in constant usage. The hydrogen daily requirement for this project is around 2.5 tons per day, which is also quite massive if you consider the hydrogen production facilities that we have today. And here you can see the picture of our pre-series assembly line in France, and also the possibility of stack the units. So basically for this unit, we are considering an average of 29 GH2 to provide this quantity of power, and they can also be stackable. So basically that's the solution that we are providing. The customer hasn't yet received the unit, hasn't yet closed the deal, but this is an ongoing project that we have with our distributor now in Nigeria that we hope to conclude in order to reduce the carbon emissions for these customers. And the biggest challenge that we have for the moment, it's to get this hydrogen. So that's the main barrier that we are identifying today, because As you see, we have a daily requirement of hydrogen of around 2.5 tons, which is quite massive. And for the moment, we don't still have the solution locally in Nigeria. So we are still looking at that and looking to provide this solution as soon as possible to this customer. But basically, this is important for you to know more about the application, the possibilities. So right now, basically, we can replace diesel gensets with these units with no emissions, with no pollution, and with no noise, basically. So that's the solution that we are providing to customers in Nigeria. This one, it's more a concrete project, but we are also in touch with different customers from the telecom and etc. that are also looking for replacing their gensets. If I give you some more information about the product itself, so here you see the dimensions of it, the total weight. So it weighs about 4 tons, each of them. We have 100 kVA power gensets with this voltage at output, as I said. So 400 and 230, we're going to have 480 volts by last quarter this year. We can work both in 50 or 60 hertz. Regarding temperature, we can go from -15 to 40 degrees. We are using the Toyota fuel cell, which is a proton exchange membrane. The battery is an EODev system life pole and 44 kilowatt hour. So like to reiterate, no emissions, no NOx. Regarding the noise levels, it's a very silent solution because we don't have moving parts, we don't have combustion inside of it, but the noise levels are still under test. So we are trying to check all the official measurements from 1 meter distance and 7 meter distance, and also the volume of filtered air that we are trying to measure right now. That we might have that shortly. Regarding the suppliers, so 80% of our components come from Europe. So as I said, all of our products, they are produced in France, and even the fuel cell from Toyota is produced in Europe, in Belgium today. And as I said, 80% of components come from Europe, 60% from France. So this is also important for us. We have a good network of dealers today. So as I have mentioned it, we have a partnership with an area which is assembling our units here in France, but also distributing and doing the maintenance in the countries where they are present. So today, like in Africa, they are already present in Algeria, but they are also present in France, Belgium, Luxembourg, Poland, Romania, Moldavia. And we also have a distributor in Australia today, Blue Diamonds, and in Canada. So it's AKA Group. We are right now closing deals with different distributors in the UK, in Netherlands, and etc. So the idea is really to go international and cover the whole world. And as I have mentioned, we have our distributor in Nigeria to this project of this customer that I have mentioned it previously, but also additional ones that will be able to provide service and also sales locally, which is Bullserve. We have closed this deal with them. It's been a couple of months ago. These are some examples of hydrogen storage systems that we have today that we use here in France to do demonstrations, but also to rent the products in France. Just to give you an idea about the solutions that we have today in Europe, and also the autonomy that we have for each of the solution, considering 80% of the load. So we estimate a consumption of around 4.24 kilograms of hydrogen per hour at full output. That's what we need for our power genset to provide 100 kVA of power. So these are some examples of hydrogen storage and also autonomies that we can have. From like small customers and small applications, we can use just bundles like these from 13 kilograms, and we can go up to 1 ton if we have a huge consumption, and if we have multiple units. So that's basically the case that we are considering for Nigeria, because they will be consuming 2 tons per day, roughly. So we need to look for bigger solutions for hydrogen storage, and these are the purity that we need for the hydrogen to work. So it's not any kind of hydrogen that we can use for the fuel cells. The quality of the hydrogen is important, and basically it's 99.97% that we need for the units to work. These are some events that we have made basically to replace diesel gensets and to show people and during events that it was totally feasible to replace them, and that we have gains in like performance because we have more efficiency. We need to mention that for diesel gensets we have 35% roughly of efficiency, our units 50%. And we have also identified that we have oversized applications normally. So for this example, we have replaced the 50 kVA, but at the end of the day, these are the graphs that we supply to customers. And at the end of the day, we see that we just had peak consumptions of 15 kVA. So basically the 50 kVA they had before, it was totally oversized. So this is also important to mention. The customers, they have access to all of these diagrams, so they can see the power consumption, the hydrogen levels they have, the battery they are using, and etc. So this is quite interesting. I'll not get into the details of this one as well. Just important to mention that we also take into account the avoided CO2 emissions. So for this example, it was used during 3 days. This is our unit in the heart of Paris. We did a demo and we have saved 156 kilograms of CO2 during 3 days. So this is also great, and we have consumed 11 kilograms of hydrogen. So this is also something that the customer has normally along with our unit. We have also did a demonstration in the desert in Saudi Arabia, and we have consumed 1.23 megawatts, and we have saved 1.24 tons of CO2 during this demonstration. We can also do customizations of the unit. So this was the one for Loxam. They have bought one basically to rent the units. This is for entities. We have also made basically to replace the electrical network while they are doing some works in the network. And we were providing power to around 50 houses in the French Alps. So this is also a good demonstration we have made during 5 months. It's still ongoing, but that was a great one. And this is also great to mention. It can also be a solution to recharge electric vehicles. So this was a demonstration we have made for Toyota Motor Europe in Belgium, as you can see, and that we were providing power to electric vehicle. So this is also a no-emission solution for a non-emission application for the mobility. So I stick to the time. So that's the end of the presentation. I hope it was clear. And if you have any questions, I'm more than happy to answer all of them. Thank you very much.
Thank you so much, Fernando. Yes, it was very clear. And yes, there are many questions. So I'll just shoot them at you. Some are easy, some are less easy. Amadou is asking, what is the lifetime of your device? And lifetime and efficiency. Is there such a way to describe it?
Yeah, sure. So basically for the full cell, that's the main component that we estimate the lifetime in hours. So it's 13,000 hours. Basically, it's not only the lifespan, but it's the certified efficiency that Toyota supplies. So basically, we guarantee that the full cell is providing power with a 50% efficiency during 13,000 hours. After that, we're going to have more heat than power in the outlet of heat, but the customer can still use the unit. It's just that the efficiency is going to drop. But we recommend the full cell replacement after 13,000 hours. And this is possible to do. It's not necessary. It's not needed to replace the whole unit, only the full cell compartment.
Other question, how do you compare, like you've shown several examples of your replacing a diesel generator. How does one of your units compare to KVAs in diesel generator? Like on your side, you have one size, or do you have different sizes? And does this match exactly a 50 kVA, 100 kVA, 500 kVA traditional diesel generator?
Basically, it's the same thing. So we use the same ISOs that they need for diesel gensets. Our product is 100 kVA as prime power generator. So basically, we can replace a diesel genset of 100 kVA. It's not exactly the same principle of functioning because we take the charge much more quickly than a diesel genset. As soon as you turn it on, you got the 100 kVA. But basically, as ISO, if we talk about ratings and power ratings, it's the same application. So basically, you can replace 100 kVA diesel genset by our unit. And as I have mentioned, we can we can use multiple units for more power. So if you require 300 kVA, we can have 3 units. If you have 1 mega VA that you want to replace a diesel genset, we can supply you 10 units. This is also stackable, so you can reduce the total surface footprint, and then we can go up and up. And we can also have a hybrid solution between diesel gensets and our gensets with batteries and etc. So basically is to optimize the power. So if the customer just have a peak of consumption, they can keep their diesel genset that will only run for a few hours a year, and then the normal charge we take it with our product with no emissions. So this is also possible to use. We are able to communicate with different devices.
All right, so those were the easy questions.
Okay.
A difficult question. Atharva and an anonymous listener are very interested in the costs and how it compares to traditional diesel generators.
Yeah.
I'm sure it's not possible to give an exact figure, but at least some order of magnitude and some feeling for the listeners here, because we have several questions, I think, of people who are in Nigeria running on diesel generators, and they would like to know if this is a feasible solution for them.
Yes, of course. So basically, it's not possible only to compare the total price of purchase of a diesel genset and our units. Why? Because as I mentioned, we have more efficiency. So we are talking about 50% efficiency, and we have more energy in 1 kilogram of hydrogen. So basically in 1 kilogram of hydrogen, you have basically 33 kilowatt hour of energy against 10 kilowatt hour in 1 liter of diesel. You know, so basically we have more energy in 1 kilogram of hydrogen, and we have more efficiency in our product. And also we have low maintenance because, as I said, basically we're replacing filters on these units. And then that's why we are talking about total cost of ownership. So we have performed a calculator where we check the total cost of ownership of the whole unit, and we compare with the diesel genset. So it's if we compare only the price of the unit, it's going to be 6 times more, let's say, of a diesel genset from 100 kVA ratio. Like the exact figures, I invite you to contact us, and then we can send you the quote for that, because it also depends on the volume. So if we're talking about just 1 unit, it's going to be one price. If we're talking about 20 units, it's going to be a different one. And also depends on the region, you know, so it's quite difficult for us to estimate and give a price for that. But as I mentioned, it's important to consider total cost of ownership. So this is something that we can do if you have the run hours of the diesel genset, if you have the power, and then we can do this comparison of how many units that we need, and then we can provide you like how much is going to be more expensive for you to have this solution rather than the diesel genset. But it's important to mention that the hydrogen prices are dropping and the diesel prices are increasing. So this is also that we take into account in the total cost of ownership. We do estimations in like 10 years, like to estimate the differences. But it's quite complex to discuss just the price of the diesel genset and the price of this product, because this is not the same application. So yeah, I hope I have answered the questions.
Yes, the answer is please contact you, and then people will discuss and find out. Yes. Other question, other difficult one, and you were transparent about this in your case study for this company in Nigeria. There seems to be a problem of feedstock. How do you think that project in Nigeria will solve this problem of actually procuring hydrogen?
Yeah, basically that's the barrier that I said. So unfortunately, we don't have this quantity of hydrogen available in Nigeria for the moment for this customer. So right now we have the interest for this company. It's a big company, and we have our distributor locally working on that as well. But right now we are contacting people that are interested in producing hydrogen. Some people, some companies here in France, but also in Europe, to provide this production facility in Nigeria. So that's the way we are thinking about this, because it's a massive quantity, and we are thinking about producing it locally. So that's when we're looking for the solution. And if there's somebody hearing that can supply this solution for the hydrogen production, you can contact me. We'll be more than happy to discuss about this, but we are looking for this local hydrogen production. For the moment, we don't have it.
Maybe a stupid question, but would it be realistic or conceivable that this client sets up its own hydrogen production facility for his own concept?
Yeah. Actually, we'll be considering if there's a company that's interested in producing hydrogen in Nigeria and providing this hydrogen to multiple companies, that's better. It's far better because we have economies and it's more efficiency regarding that. But since they are looking for this alternative, like as soon as possible, let's say, depending on the project and all of the costs and the overall efficiency of the system, this is something that we can consider because this is a big company. They have different units in Nigeria. So this is just the first project, but they might be multiplying this for different factories they have. So this is also something that can reuse this hydrogen that's produced for other factories. So this is something that we are considering for the moment. But it would be much better if we could have like companies like we have here in France that can provide these tube trailers already with 1 ton of hydrogen, and then we can just connect to our power gen set and produce power. That would be far easier, but unfortunately we don't still have that. So we're looking for solutions,
You will get contacted after today, no worries.
I hope so.
And then last question from Pascal. Since there will be business in Africa, because you are very ecstatic and your solutions can replace a lot of the diesel generators that people use here in Africa. Since there will be business for you in Africa, is there an opportunity to produce some of the parts in Africa as well, or assembling your units or doing something a bit more local in the African market?
Yeah. For the moment, we are not yet considering, of course, that we are identifying because we have different markets in the US, in Australia, like in Asia, North America. So we might need to have different assembly lines in the near future. But for the moment, we are with this production facility of 600 units per year that we intend to provide customers for the moment, for the short and medium term, let's say, with our production facility in France. And as we evolve and as we get more market demand in different countries, we might evaluate a production facility in other countries, but not for the moment.
All right, all right. Well, thank you very much. There's many more questions for you specifically, Fernando.
Okay.
Make sure to share these with you.
Yeah, sure. I'll be more than happy to presentation.
Because it's been a long day already for the listeners and also for me. So I would like to conclude today, and just for those of you who are still with us, just a few words about upcoming events, upcoming AFSIA events. We have, if you like today's and tomorrow's e-conference on green hydrogen, well, for sure you should like our next big e-conference on storage technologies. It will be at the beginning of May, so I warmly invite you to sign up for this one. We have the AFSIA Solar Awards, the 2022 edition, which will take place live back with AEF, the Africa Energy Forum. And we really look forward to attending an event physically, just like everybody has been expecting, dreaming about for quite a long time. So we will be there in Brussels in June. And the applications are open, by the way, so make sure you participate. And then we will also have our own conference together with our friends from Renew Africa Biz. It will be in Cape Town at the end of September and really focused on renewables investment. So if you're a company looking for project developers and looking to fund those projects, this is the place. If you are a project developer and you are looking to connect and meet new financing partners, this is definitely the place